Hey class, today we're going to be talking about systems of equations. Up until now, we've been having an equation written out in this format, but we've only been dealing with one at a time. A system of equations is when you have equations, but there are two or more equations happening at the same time. So, what does a system of equations look like? Well, if I had two equations like this, I would have two equations in slope-intercept form. And what we would be looking for is for an answer to both of the equations that would make them both true. When we drew a line for just one equation, we were looking for the answers for just one equation. But when we're looking for an answer for a system of equations, we are looking for something that's going to satisfy both of the equations at the same time. Okay, so let's go ahead and get that written down as a definition. A solution or answer to a system of equations is a solution to a system is a point. Okay, meaning a coordinate point on a graph, right, where there's an x and there's a y. So this is a point on the graph that makes all of the equations true. Okay, it can't make just one of them true. It has to make all of them true. Okay, so to see what this looks like, we're going to kind of do some example problems we're going to explore. So this one says we have a point here. The point is at 10, 2, and we want to know if this point could be a solution to these equations. And then we're also going to do the same thing with problem number 2. But how do you even check to see if it's a solution? Well, remember that this point has an x value and a y value. So what we're going to do is we're going to substitute those values in to both equations and just see if it's true. Okay, so let's go ahead and do number 1 together, and I'll show you what this looks like. We're going to take this first equation right here, and I'm going to rewrite it with 10 as my x and 2 as my y. So as I rewrite it, I'm going to say 10 instead of x minus 2y. I'm going to put the y value as 2 right there, equals 8. Okay, so using this x and y in this equation, just going to wait for that to not blur. There we go. I'm going to check and see if this is a true statement or not a true statement by solving it. So looking right here, order of operations says I should solve this multiplication problem first. Negative 2 times 2 is negative 4. 10 minus 4 equals 8. Is that true? That is not true. Okay, so this would not be a solution because it didn't work. So let's see if the others would work. Now some of you are asking, wait, Miss Jones, we didn't even try the other equation. Well, that's because I don't have to. In order for this to be the answer, it would have to work in both of the equations. So as soon as it doesn't work, I can successfully say, no, this is not a solution, and I can check another problem. Okay, so let's try number 2. We're going to do the same process. I'm going to substitute the x and the y value into this first equation and see if it's true. Okay, so every time there's an x, I'm going to put a 10 there. So 2 times 10 minus 5. Now instead of y, I'm going to put the y value, which is 2, equals 10. Okay, let's see if this is true. Okay, 2 times 10 is 20. Negative 5 times 2 is negative 10. Is 20 minus 10, 10? Yes, this is a true statement. Okay, so that means that this point is a solution, is an answer to this equation. But in order for this to be true for both of them, we're going to have to check both. Okay, so I'm going to draw a little line here. And we're going to check the other one. Okay, so instead of x, I'm going to write the 10. Instead of y, I'm going to write the 2. And this one's pretty simple. Is 10 minus 2 8? Yes, this is true. So because this point was true in both of the equations, it is the answer to this system of equations. Okay, so what we're looking for is we're looking for a point, x and a y, that is true. Okay, now this is a lot of work. So we're going to show you a way that you can use graphing to find the solution very quickly and easily. Okay, so first, let's go ahead and get the gist of it down right here. A solution to a system of equations looks like a point. Okay, we've established that. We're getting a coordinate point, an x and a y, where the equations, we know they both have to be true, but when we graph them, the equations will intersect. Okay, so we're going to go ahead and draw a little graph just right down here where you've got some space. If you were to have two equations on the line, let's say you had one equation right here that you've graphed and another one going this way. Okay, this is a system of equations because it's two equations that we've graphed, and the solution is where they intersect right there. That point tells me that they are true in both equations. Okay, so we are looking for this point to be the solution. All right, let's try some together. Here we have a system of equations because there's more than one, there's two of them. I'm going to zoom in real quick so we can see the graph nicely. Okay. Alright, so looking at this first equation right here, I'm going to have to use what I know about slope-intercept form and graph the first equation. Okay, y equals 3x minus 4. Well, my y-intercept is negative 4, so I would draw that first. 1, 2, 3, 4. There it is. And then I'm going to use the slope of 3. I'm going to make it a fraction. And I'm going to rise 3, 1, 2, 3, and run 1. Now, the trick to doing anything where you're looking for answers on a graph is you're going to want to draw a straight line. So I'm going to use a separate piece of paper to help me get a straight line. Without this, your answers can be just a little bit off. Okay, so I'm going to use this piece of paper to help me draw a straight line all the way across the graph. Boom, there it is. There is the first equation. Now we're going to do the same thing with the second equation and graph it on this same coordinate plane. For the second equation, the y-intercept is at positive 2. So there's my first line. The slope for this one is negative 3. And when I make it a fraction, it'll be negative 3 over 1. Okay, so this time instead of going up for my slope, I'm going down because it's negative. So I'll go down 1, 2, 3, and over 1. Oh, looks like we're using that same point right there. So when I draw my line really straight with a piece of paper, there's going to be a point where both of those lines intersect. You see it right there? That point is my answer. That is the point where both lines are true at the same time. So when I write down my answer, I'm going to need to just write down the coordinates right there. That looks like the x value is 1 and the y value is -1. So that is my answer. My answer is this point right here. Okay, let's try another one and see how it goes. Okay, for this one, we're going to graph the first equation at y equals 1/3 x plus 3. So my y-intercept is at +3. 1, 2, 3. There it is. And I'm going to use the slope +1/3, so up 1 over 3. And now I'm ready to draw my first very straight line using my straight edge. Okay. Now we're ready for the next one. My second equation, y equals -2/3 x minus 3. So I'll start at the y-intercept of -3. 1, 2, 3, right there. And this one has a negative slope. So that means I'm going to go down 2, and I'm going to run 3. 1, 2, 3. Okay? Now remember, a line doesn't just go this way, it also goes the other way. So they will intersect somewhere. Let's see where. Okay, hopefully I can get my lines nice and straight so that we end up on a point that is intersecting. Okay, and there you go. You can see that there's a point right here where we are intersecting. Now, unfortunately, my drawing is not exactly perfect because I'm not a computer. So I'm going to remember that if I was to draw straight, the line would probably be right there. Okay, so when I write my answer, I'm going to use that point as a solution. Okay, looks like that point is at -1, 2, 3, 4, 5 in the x direction and +1. So the solution for both of these at the same time is only at this point. All right, we're going to do one more together to show you an interesting situation, and then I'm going to let you practice on your own. So here we go. This is kind of your what if question. Oh no, something weird is about to happen. That's okay, we can do it. What if? Okay, so we're going to start off with our method just like normal. I'm going to graph the first equation. I'm going to start at the y-intercept of -2, right there. And I'm going to graph the slope 5/4. So up 5, 1, 2, 3, 4, 5, run 4. 1, 2, 3, 4, right there. Use my straight edge so I get a nice straight line. And there it is. All right, first equation, done. Let's do the second equation. The second equation has a slope of, an intercept of -1 right there. Now here's the interesting part. The slope is exactly the same as the other one we just did. And this is what makes this particular problem so interesting. So when we use our slope of rise 5 and run 4, let's try it. It happens that these two lines are parallel. They will never intersect. So the answer to this one is no solution, because they don't ever cross. All right, you go ahead and finish the rest of the problems on this paper,